Hello friends, this is the part 1 video of adrenergic system. The role of the adrenergic system in our body is at the time of flight, fear and fight. Now, another role is at the time of stress. There is more increase in heart rate and it will increase the stroke volume, and finally cardiac output will also get increased. And now from different parts of our body to skin to GIT, at the time of these situations, means at the time of flight, fear, these through different organs, the blood get transported to the needy organs. The needy organs are skeletal muscles, heart, and the brain also. And now talking about the neurotransmitters that are in the adrenergic systems are noradrenaline, dopamine, adrenaline. Okay, noradrenaline also called norepinephrine, and adrenaline also epinephrine. Now the adrenergic receptors are divided into two, that is alpha and beta, and alpha receptor again subdivided into alpha 1 and alpha 2, and beta receptor again subdivided into beta 1, beta 2 and beta 3. Beta 3 is not important, but also it is present in the, where does it beta 2 receptor, beta 3 receptor present. The beta 1 receptor is present in the heart and beta 2 in the lungs. Okay, now how to memorize this is, there is one heart and there is two lungs, and the beta 3 receptor is present in the smooth muscle, in the adipose tissues. Okay, now other is the norepinephrine synthesis steps are, first of all there is synthesis of norepinephrine, and there is storage. The norepinephrine there, it will be no, first there is the synthesis of norepinephrine, and they are stored in the vesicles, and they will be released of the norepinephrine, and they get bind to the receptors, and they are present on the effector tissue side, and there will be removal of norepinephrine, and finally metabolism and elevation. Okay, now I will describe this synthesis of norepinephrine, the steps, okay, in the diagram. This is the important for theory. Now these are the neurons coming, these are the sympathetic neurons coming from the thoracic regions. Okay, and this is the first synapse point. This is the presynaptic neurons, this is the postsynaptic neurons, and this is the nerve ending. This is the postsynaptic nerve ending. Okay, now what happens that when you eat the proteins, it get converted into amino acids, and the amino acids absorbed by the from the GIT, and this goes into the circulations. Okay, and in the circulation, one of the amino acids is tyrosine. The tyrosine, through the tyrosine receptor present in this nerve ending, and it will uptake the tyrosine. Okay, and the tyrosine will be converted into dopa through by the enzyme tyrosine hydroxylase. Okay, and dopa will be converted into dopamine through the enzyme dopa decarboxylase. Okay, this can be remembered through the structure. Okay, now this is the structure of tyrosine, where there is benzene ring and one hydroxide. So what are the catecholamines? First of all this tyrosine, all this dopamine and other is norepinephrine, epinephrine, they are called catecholamines. Why they are called catecholamines? Because catecholamine means there is one amine group and other catechol ring. The catechol, what is catechol ring? The catechol ring is one benzene ring with 2 or 3 hydroxide. Okay, this is the one amino group and other hydroxide is with benzene ring. These are the catecholamines. Now through the tyrosine hydroxidase, this hydroxide is added and it get converted into dopa, and there is this carbon dioxide, there is carboxylic, there is this carboxylic acid, and this carboxylic acid is removed through decarboxylase. Okay, so dopa decarboxylase, here is dopa decarboxylase, and this dopamine will be transported into the vesicles through dopamine transporters, and now this dopamine will get converted into the norepinephrine through the enzyme called dopamine beta hydroxylase. Okay, if these dopamine remain here, it will be catalyzed by monoamine oxidase. So what is monoamine? Monoamine means those amines which are derived from single amines. Okay, those those are neurotransmitters which are derived from single amines. Okay, now these dopamine can be called monoamines. It can derived from this tyrosine, and norepinephrine is monoamine. It derived from dopamine, and epinephrine monoamine it is derived from norepinephrine. Okay, it is the monoamine. Other monoamine as serotonin, it is derived from tryptophan. Other is histidine, it is derived from histamine. Now, okay, now when there is influx of sodium, okay, there is depolarization. In depolarization, sensitive calcium channel opens. Now calcium enter inside, and what does it do is it binds with these synaptotaxin receptors. It binds with synaptotaxin receptors, and when these calciums bind here at this point, okay, it will open. Okay, and synaptobravin will bind here, and there is fusion of these vesicles to this nerve-ending membrane and release of the noradrenaline or norepinephrine. Okay, and most of these norepinephrine's will bind to the effector site where there is present of alpha-2 adrenergic receptors and beta-1 adrenergic receptors and beta-2 adrenergic receptors and some of the alpha-2 adrenergic receptors. Alpha-2 adrenergic receptor in its membrane site, okay, nerve ending membrane site, and it is always coupled with G inhibitory protein. It may inhibit this synthesis, okay, and G alpha 2 is coupled with GQ and beta 1 beta 2 coupled with G stimulatory protein. Now some of the noradrenaline is catalyzed by these catechol O methyl transferase, okay, by adding this methyl group to this benzene ring by removing the one hydroxide which is present over here. Okay, now some of these go into circulation, they go in the liver, kidney, they are also catabolized by COMT and MOA, and some of the noradrenaline is reuptake, okay, and some of these are also reuptake by these vesicles, and some of them are destroyed by monoamine oxidase. It will convert into inactive metabolites and it will be passed through the urine. And what I'm shown, this is some of the vesicles. These vesicles, once they are fused with this membrane and the noradrenal release, then again these vesicles are reuptake. I'm showing this figure. Now this is part 1, I'm making this part 2. Okay, as the main thing in this topic, in this today topic, is the synthesis of this norepinephrine. Okay, you have to memorize this, and this can be done through this diagram. You have to draw this diagram in exam this much. Okay, and then it will be fine. Bye bye.